Moving on to 4.2, but first we're going to have to identify the axis of symmetry. Remember, the axis of symmetry is the x value of your vertex, and since it is a line, it's always going to be x equals. And for this particular one, remember we look at inside our parenthesis and we take the opposite sign. So our axis of symmetry is x equals -7. So today we're going to be doing 4.2, standard form of a quadratic function. So this is the standard form of a quadratic function. Again, you will have this in your memory for the next couple weeks. Ax squared plus bx plus c. Again, remember a, b, and c are just numbers. A couple of the properties we've already talked about. Remember, if the number out front of your x squared term is greater than 1, it's a stretch. If it's less than 1 or if it's a fraction, it is a compression. To find the axis of symmetry, use -b over 2a. And again, your y-intercept is 0 and your last term or your c value. So we have to identify the vertex, axis, symmetry, maximum, and range of this function here. So we first need to start with finding our axis of symmetry using the formula x equals -b over 2a. And when we do this, we have to identify our b. So we have negative, and again, when I am replacing variables with numbers, I like to use parentheses in case there are negatives. So I replace my a and b with parentheses, and I look for my b term. Again, ax squared plus bx plus c. So my b is the number in front of my x term, which is 8. And my a is the number in front of my x squared term, which is 2. And then I simplify. A negative times 8 is -8 over 2 times 2, which is 4, and -8 divided by 4 is a -2. So our axis of symmetry is x equals -2. Which then brings us to our vertex. Remember, your axis of symmetry is this x value of your vertex. So we just found our x value of our vertex to be -2. But then we have to plug it back in to find our y value. So if we plug in -2 up top here, what do we get? So -2 squared is 4 times 2, we get 8. So here's 8. And then 8 times -2 is -16, and then we gotta subtract 2. So 8 minus 16 is -8, minus 2 we get -10. So our vertex is at -2, -10. Next we have to determine if we have a max or a min value. Since our graph will open up because the number out front of our x squared term is positive, we will have a min. And remember, your min is always the y value of your vertex. So our minimum value will be -10. And the last part is to identify our range. So remember, range we represent with a big letter R. Range is the y values. And again, if we're starting, our lowest point is -10 and our graph goes up, it'll be y greater than or equal to our minimum value, or the y value of your vertex, so -10. So I know it's a lot to remember, but again, once you find your axis of symmetry, that's the same as the x value of your vertex. Plug it back in to find your y, and then your min or max value will always be the y value of your vertex, and your range will also be the same as your y value of your vertex. So I'm going to let you guys work on this one by yourself. Identify the vertex, axis of symmetry, if we have a max or a min, and the range of our function. So when you plug in to the formula x equals -b over 2a, you should get -2/3. So our vertex x value is -2/3. When you plug that back in, you get 22/3. So our vertex is at -2/3, and y value is 22/3. which makes our axis of symmetry x equals negative 2/3. Remember, it is a line. Next, we will have a max value because the number out front of our x squared term is negative, and our max value will be 22/3, which then makes our range y less than or equal to 22/3. So next we need to use this formula, x equals negative b over 2a, to graph our function, which means we have to identify our vertex. We use the formula x equals negative b over 2a. Again, b is the number in front of your x term, so that's 2. And a is 1, so 2 times 1 is 2, and this reduces to negative 1. So our vertex is at negative 1. Plug it back in, negative 1 squared is 1. 2 times negative 1 is negative 2, plus 3. So 1 minus 2 is negative 1, plus 3 we get 2. So our vertex is at negative 1, 2. Then we can identify our y-intercept. Remember, our y-intercept is where it hits the y-axis, so our x value is 0, and we always left with our constant term at the end. So our y-intercept is 0, 3. And if you reflect that point over, remember vertex is a point of reflection, we get our 3 points, which is good enough. Connect them, and you are done. And if I asked you for the transformations of this graph, you would say left 1, up 2. So go ahead and do the same thing for this graph here. Identify your vertex, find your y-intercept, reflect that point over, and you are done. When you plug it into the formula x equals negative b over 2a, you should get our x value of 1/2. And when you plug that in to get y, you should get negative 9/2. So your vertex is at 1/2 negative 9.5, which is negative 4.5. And your y-intercept is negative 5. Reflect it over, and you get your graph. And this is what we'll be working on tomorrow in class.